All right, here we have our fifth thermodynamic question. Your 0.25 kilogram hands have a specific heat of 4,300 joules per kilogram degree Celsius, and you warm them up with 10,000 joules of energy from a fire. They started at 21 degrees Celsius. What temperature do they end up at? So we have our sketch, our givens. We have a mass for your hands, 0.25 kilograms. We have the specific heat of your hands, 4,300 joules per kilogram degree Celsius. And we have the amount of energy, 10,000 joules of energy. We also have a starting temperature, so Ti is 21 degrees Celsius, and we want to know the final temperature, so that's going to be Tf. Our equation is Q equals mc delta T. So we want to get T final by itself. It's inside our delta T because delta T is equal to T final minus T initial. Any change is the final value minus initial value. So first thing I want to do is get delta T by itself. So I'd have to divide both sides by mc. So I get delta T is equal to Q over mc. Then I can replace delta T with T final minus T initial. I want to get T final by itself, and I'm subtracting Ti from it, so I need to add Ti to both sides. So my T final is going to end up being Q over mc plus Ti. Make sure it's not in the numerator any part of this fraction because we had to add it to this fraction by itself. So whatever we get for this fraction, we're going to add Ti to it. So now we're clear to substitute because my unknown is isolated. Everything else is in my givens. So my final temperature is going to be the amount of energy, 10,000 divided by mass of 0.25, and the specific heat, 4,300. Make sure to put this all in parentheses so your graphing calculator does it correctly. And then we add on 21 degrees after we get that fraction. So if we calculate this fraction, add 21 to it, we should get a final temperature of 30.3 degrees Celsius. 3 significant figures, proper units, answers box.